Okay, we're going to solve linear equations by graphing. Now, you might be saying, we've already been doing that, Mr. Evans. I know. We're going to look at a special case this time. Before I read to you how to do it, it might help you to actually see a problem. So it says solve negative x plus 1 equals 2x minus 5 by graphing, and then check your solution. But if you look at these two equations, or one equation here, you look at both sides of it, you might notice something's missing. There's no y. Both have an x. And so we're supposed to graph it, and it doesn't give us a y. Now let's talk about how we can handle that. So looking up here, it says the first step is to solve an equation like that, where you have constant terms and variable terms and on both sides, but it's the same variable. It says write two linear equations. In other words, write both of these as two different equations and then insert a y in the front of each one. And the reason you can do that is they equal each other. So since they equal each other, they would both equal the same thing. So you can put a y equals to both of them because they both equal the same thing, therefore they both equal y. So let's graph the system of linear equations as a second step. And whatever you get for the x value, that will be your answer for the x. We'll ignore the y value because we kind of just put the y in there. All right, that was a lot of talking. Let's see if we can make sense of it. So we have this actual equation here we need to solve for. So I'm going to say y equals this first part of the equation, a negative x plus 1. And I'm also going to say y equals a 2x minus 5. And now we need to graph it. So I went ahead and wrote those equations on this coordinate plane. And remember, the graph is not challenging at all. We just find the m and the b. So the m, or the slope, is a negative 1 over 1, and the b equals 1. Easy. And I can use a different color marker for the other equation just to help us keep track. So the m on this one would be a 2. We'll write it as a 2 over 1. And the b, y-intercept, same thing, will be a negative 5. So let's graph both of these. If the b is 1, we'll start up 1 on the y-axis, 1 up from the origin, and we'll do rise over run, but we'll go down because it's negative. So we'll go down 1 over 1, down 1 over 1, and one continuous line. There we go. Goes on for infinity. Easy enough. Now we'll go ahead and do the other one now. And that says that the b is a negative 5. And that the m is 2 over 1. So we'll start at negative 5. And then 2 over 1 means we rise 2, 1, 2, and go over 1. Rise 2 is just counting over 1. Oh, I think I see where they intersect. Let's draw this continuous line here. Okay? Looks like we found it. Looks like to me they're intersecting at x being 2, 1, 2, and y being negative 1. However, remember the instructions. It said the x value of the solution of the system of equations is the solution. So we're really looking at the x value here. And here we're saying that x equals 2. Right? So remember that it also says to check the work, not just to solve the work. So we want to check it. In order to check it, we would need to substitute a 2 into the equation. Let's see if that works. So the original equation, let me take it back there, is up here. So negative 2, remember x is 2, plus 1 equals 2 times 2 minus 5. This would be a negative 1. This should be a 4 minus 5, which is also a negative 1. Oh, it does work out. X is a negative 1. We did it right. Good job. All right. So I created another problem I do want you to take notes on. It's very similar to the one we just did. So remember, the first thing you're going to do, the first step, is you're going to look at these equations, see that they equal each other, or look at this equation, see that right now it's 1. You're going to create it as two equations with a y in front. Y equals 2x plus 3, and the other one is y equals x plus 2. Then you're going to graph both of these using any of the methods of graphing that you prefer. I personally think since it's set up in the slope-intercept form, I'm just going to find the m and the b. And I'll do the same thing with the other one, the m and the b. Okay, and now we just need to graph them. So on the first one, the b equals 3. So let me change marker to green so we can follow the line with the equation. So 1, 2, 3. I'm going to rise 2 over 1. Just missed you. Rise 2 over 1. Rise 2 over 1. And I'll go down 2 over 1. Okay. Very good. There's our first line. Yay. Let's do our second one. B is 2, so we'll start at 2. And we'll rise 1 up 1. Rise 1 up 1, almost. Rise 1 up 1. Actually, let me go the other way. Down 1 over 1, because I think that's where we're actually connect. Down 1 over 1. So it looks like if we were to draw our line, oops, there's our intersection. There's the solution between them. And so in this one, x would be a negative 1, and y would be a positive 1. However, remember, we artificially added that y in there, right? So we're really just looking at the x. The x is a negative 1. And so if we were to substitute that negative 1 back into the original equation, let's see if it would be true or false. Put a negative 1 in here for the x, plus 3 equals a negative 1 here for the x. Okay, let's see. The negative 2 plus 3 equaling a negative 1. Or, I'm sorry, equaling a positive 1. 2 take away 1 is 1. And so we'd have a 1 equals 1. Yay, we did it right, and we checked it to make sure.